Before we talk about the nuclei of atoms, I think we should talk about the char how much what is the charge of a proton and electron. So we want to know the charge. Where we want to know the charge. I'm gonna represent the charge. So I'm gonna go into a little physics here, not too much. Charge, I'm gonna write it in the charge. It's the same as Q. So it's that's how you do it in physics. That's a convention. So what is the charge of an electron? Q sub E is charge of an electron, and what is the charge of a proton? Of course, you know what the charge of a neutron is, because the charge of a neutron is zero. It's neutral. So what is the charge of a proton? The charge of a proton is the charge of a proton is 1.6 times 10 raised to the negative 19. What units? Coulombs. Who's Coulomb? I don't think I can't. He's a famous physicist, I believe. Yeah, he's a famous physicist that developed Coulomb's law that that relates force forces to charges. So that is fantastic. And the charge of an electron, as you might expect, is the total opposite. So so this is positive. So the charge of an electron is gonna be negative 1.6 times 10 raised to the negative 19 coulombs. So I think this is important. This is quite important, and this is quite important. So introducing to uh, since I'm introducing you to the idea of charges, why not show you Coulomb's law? So Coulomb's law states that the force, the force of attraction between two charges, or Coulomb's force Coulomb, whatever you call it, is equal to some constant k, but I like to some constant k. Let's just be simple right here, times charge of the charge the charge of the first the charge of the first thing, and the charge of the second, all over r squared. So what what is the first charge? What is the charge of the first thing? The charge of the first thing is, it could be the charge of the electron. It could be the charge of the proton. So I'm just gonna simplify things, since we're teaching chemistry. This is also, you can also write it as charge of the proton, and this is the charge of the electron. Charge of the electron, and then r squared is the distance between them. R squared is the distance between them. Distance between between charges. Charges. And then what k is what you call a constant, something that doesn't change, unless if there was a miscalculation in the constant, then it will change. But it's it's natural, so it wouldn't change. So k in this case is approximately 9.0 times 10 raised to the 9 power, I believe. So why did I kind of hesitated to use k a while ago? In in some classes you might use k as this 1 over 4 pi epsilon naught, and I'm not so sure how to explain epsilon not I'm not too comfortable yet, so I'll just leave k there and give you this. But these are the same things, so you can get the value of epsilon naught by multiplying 4 pi. Oh, no, by multiply by getting 1 over 4 pi 9 point times 9.0 times 10 raised to the 9th power. There, I have trouble speaking. See you in the next one.